Okay, so we're going to go back to lesson 10.6, which is all about pulleys. So in the previous lessons, we had a look at some pulley questions, but where you had the diagram drawn for you and you just had to calculate the tension and the acceleration using simultaneous equations. So now what we're going to look at is where you have to draw diagrams for yourself, and there's going to be a couple of interesting little twists, including using Suvat equations with this. So the first example we're going to look at is example 13. And it talks about two masses, 2m and 3m, attached to the light inextensible string that goes over a pulley. Nothing different about this setup. It's pretty standard question setup, and what we can do is we can start off by drawing the diagram. We're going to have P straight up and then Q down on the other side, and we have the pulley that the string is draped over at the top here. Okay, so that's our P and Q, and we can put in all of the forces on this. So we see that P is 2m, so there's a 2mg force pulling it down. Q is 3m, so it's 3mg pulling it down. And we've got the tension going up. And the other thing we have to do before we start is decide on the positive direction. So that's the direction you think it's going to move. And they've got to match. So we think that Q is going to go down because it's heavier than P, 3mg to 2mg. So we'd expect that the Q pulls down P, and what would happen is that P would go up. Okay, so those two have to match. If Q moves down, then P will move up, therefore the positive directions match with each other. Then we need to resolve each of them separately. So we start off, we can do P first. So on P, the forces, the tension pulling it up is positive, it's going in the positive direction, and the 2mg is negative. Then we do F equals ma, like always. So T minus 2mg is the force, and M is, well, it's not a single M, is it? That M in here is the mass, and the mass of P is 2m, so it's 2ma. Meanwhile, we can do the same for Q. So the force is 3mg is positive, because the positive direction is down, so we have to match the positive direction with the force pulling down. And the T is in the negative direction. So when we do force equals mass times acceleration, we get 3mg minus T equals 3m, because that's the mass of our weight Q times acceleration. Okay, so then we've got two equations. There are equations of motion for P and for Q, and then from there all we're going to do is we're going to solve them simultaneously. We're looking for the acceleration and the tension in the string. Now there's a lot of unknowns in it, there's a lot of algebra, but it will work the same. So firstly I'm going to rearrange this one. This can become T equals 2ma plus 2mg. And then I'm going to substitute it into the one here. So this is 3mg minus, and then we put 2ma plus 2mg in instead of T. And we get that. Expand my back bracket, taking special care of the minus sign. Will apply to both parts. And then we've got mg and ma expressions. So I'll add the ma expressions to that side and simplify the mg. So it's 3mg minus 2mg, which is 1mg. And we add 2ma to both sides, so it's 5ma. At this point, we should see that the m's are going to cancel. We can divide both sides by m to get rid of those. So then I just have that g is equal to 5a, and a is g over 5, which g is 9.8. So when we divide that on our calculator, we'll get 1.96 meters per second squared. That's the acceleration. The other thing it asks us for in part C is the tension in the string. So to find the tension, all we're going to do is we're going to take that and we're going to substitute back into my original equation up here. So T equals, bring it down, T equals 2m times 1.96 plus 2mg. And we don't know m, but we can work out how many m's we've got. So 2 times 1.96 plus 2 times 9.8. So T is 23.52 m, right? That's the mass that we're given at the start of the question, and this will still be in newtons. So M is the M from the mass of the objects, and N is for the newtons. And that makes sense, right? The tension is dependent on what the actual mass is. The more the mass is, the higher the tension of the string is going to be. So that's up to part C. Then we've got 3 parts of the question left, D, E and F. So this is part D now we're going to move on to. So part D asks us about the pulley. It says find the force exerted by the pulley on the string. Now you've got to think about what's happening with the pulley. The pulley is having the string pull down on it. So although the tension is pulling the P and the Q up, the tension is having a downward force because it's taking the whole weight of the whole strain from objects P and Q. So the pulley, if we just think about the pulley and forget about the objects, is experiencing 2 tension forces, right? The tension from each side of the rope. So the overall force experienced by the pulley will be 2T. And we just worked out that T is 23.52 M. So the pulley will end up with 47.04 M newtons pulling down it. Okay, so because the pulley is only in contact with the string, that's what we look at. We look at the string and it's 2 lots of tension, 1 from each side. Fairly standard question about the pulley, it's just something to remember, it's 2 lots of T. Then we move on, and part E is a little bit of a change, and it's a change from what we've done before, because it asks you about the distance Q has moved in the first 4 seconds of motion. So what that's asking for is for the Suvat equations to be used to find out that information. So let's have a look at what variables from Suvat that we know. So if we write part E here, so from Suvat, it's asking us to find the distance moved, which is S. It's asking us about Q in the first 4 seconds, so T is 4. And then we're going to need some more information. We've already got the acceleration. We've got that it's 1.96. That's for both P and for Q. Remember, they accelerate at the same way at the same time. So we just need one more piece of information. And the other piece of information is in the question. So if we look back in the question, it tells you the system is released from rest. So anytime something is released from rest, that's going to tell you about the velocity. The velocity at that point is 0. So at the start, U, the initial velocity, is equal to 0. Okay, so this is U equals 0, and then we have enough information so we can use that S equals UT plus 1/2 AT squared. So S is 4 times 0 plus 1/2 times 1.96 times 4 squared. Pop that all into your calculator and you will get 0.5 times 1.96 times 4 squared is 15.68 meters. Right, and because it's mechanics, we should be putting our answers to 3 significant figures. So 15.7 to 3 significant figures. Okay, so it's just the use of Suvat. The final bit of this question is asked us how it affects the fact that the pulley is smooth affects the calculation. So a smooth pulley means that there is no friction. And that means that the tension in the rope is not going to change depending on which way it's going. So if there was friction, the side and the side going towards the motion, in the direction of motion, would experience a resistance from the rope moving over the pulley. And that would change the tension on the rope. One side of the rope would have a higher strain because it would also be fighting against friction. So the assumption that it's smooth is that there's no friction, and importantly, that the tension is the same on both sides. Okay, again, that's a standard modelling assumption. It's always going to be a smooth pulley, and the answer is always going to be that the tension is the same on both sides of the pulley. Okay, that's example 13.